Hi everyone. In this video, I'm going to tell you about SR latch that is made up of NOR gates. So there are four different types of latches and flip-flops we have. Flip-flop and latch both are same. One is level triggered, another one is edge triggered. Flip-flop is an edge triggered and latch is level triggered. Actually, there are four different types of flip-flops we have. Uh, Flip-flops are of four types. One is SR flip-flop, second one JK flip-flop, and third D flip-flop, fourth one T flip-flop. These are the four important flip-flops we are generally commonly use everywhere. Okay, SR latch or flip-flop, SR latch or flip-flop, both are same. JK flip-flop, JK is nothing but edge triggered flip-flop. D flip-flop or D latch we can also use both, and T flip-flop. Okay, SR stands for set and reset. Set and reset. JK stands for Johnson and Kelby. Johnson and Kelby. D flip-flop is nothing but D stands for data or delay. D stands for data or delay flip-flop, whereas T means toggle. Toggle flip-flop. That means every time it changes 101010 toggling. That is the meaning of toggle. So set and reset. Now in this video we particularly learn about SR latch. SR latch. Okay, SR latch and SR flip-flop. What is the difference between latch and flip-flop? You know, flip-flop is an edge trigger device and latch is level triggered device. So if you see the simple block representation of this SR latch, this is SR latch. SR, see here, SR, JK, D, T, all these are inputs for these flip-flops or latches. Okay, here S is nothing but one input and R is another input. S is one input, R is another input. So S means set, R means reset. When S is equal to 1, output sets to 1. When R is equal to 1, output resets to 0. Reset is enabled, that means output is equal to 0. And two outputs are there as mentioned, Q1, Q bar. Q1, Q bar. Irrespective of the flip-flops or latches, the output of that particular memory element is always a true form and a complement form, Q1, Q bar. Okay, depending upon the type of the latch, the inputs will come. If it is a JK, J and K are the inputs. If it is D flip-flop, only one input is there, D. If it is T flip-flop, only one input is there, T. Okay, as we are now discussing about this SR latch, we are having two inputs, S and R, set and reset. Now, it is latch. It is latch, so it does not have a clock signal. Directly we are taking a latch device without any control of gating technology. Okay, so now I'm drawing the internal structure of SR latch. SR latch with NOR gates. SR latch with NOR gates. The same SR latch can also be constructed using NAND gates, that I will tell in the next video. So SR latch with NOR gates I am discussing now. So NOR gates, take two NOR gates. See, construction is very important. Take two NOR gates, provided you should know the operation of standard gates. Okay, take two NOR gates, a cross coupled NOR gates. Cross coupling is nothing but output of above gate connected to the input of bottom gate. So this is R, this is S, set and reset. The output of this particular, see, outputs are Q, Q bar, Q, Q bar. Now the output of one gate is connected to the input of other gate. This is cross coupling. The name of this method is cross coupling. This one. Okay, so this is first gate and this is second gate. Very simple. Okay, what I have taken? I have taken two NOR gates, top and down, top and bottom. I have taken two NOR gates, 1 and 2. Taken two inputs R and S, reset and set, outputs as Q and Q bar. Now output of first gate is connected to one of the inputs of the second gate. And similarly, output of second gate is connected to one of the inputs of the first gate. That is the simple NOR latch. Simple NOR latch. That will be now explained with the operation of the truth table. Okay. See here, S is one input, R is another input. Let us consider the state of the previous output as Qn and the next output is Qn plus 1. Here Qn means present input, present output, sorry, past output, and Qn plus 1 is the present output. See here, I will write Qn, we can call it as past output, and Qn plus 1 we call it as present output. See, if it is past output, Qn plus 1 is the present output, or we can also call it as if Qn is treated as present output, then Qn plus 1 will be future output, or we can say next output. Hope you understand. If it is Qn is presently working, Qn plus 1 is the future, next state. Present state, next state. And if it is past state, Qn plus 1 will be the present state. Okay, you can understand on your requirement. So state, now in order to fill this table, we should know the basic operation of the NOR gate. Okay, what is the output of NOR gate when both are zeros? NOR gate, simply I am taking NOR gate here. NOR gate, yes, sorry, some AB, output Y, 0 0 0 1 1 0 1 1. OR gate is 1 when any of the inputs is 1. Now opposite is the case with NOR gate. Okay, this is the NOR gate truth table. According to this truth table, we are going to now design this SR latch table. Okay, so when both are zeros, output is 1, and remaining cases output is 0. That is NOR gate. Now take SR 0 0 and 0, present state. 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. What is the meaning of this one? Is, see, first two states as a set, second two states as a test, as a set, and third and fourth, these are S sets. What do you mean by this one? See, first two states will say what is the output Qn plus 1 when SR are zeros and present state as 0 and present state as 1. And what is the output when present state is 0 when SR are 0 1 and when present state is 1 when SR are 0 1. And similarly 1 0 for Q is equal to 0 and Q is equal to 1, and similarly this one. Okay, every time we are assuming the present state as 0. Present output is 0. What will be the next output? And similarly present output is 1. What will be the next output? Like that. So now consider R is equal to 0. So what is the input of the first gate? R is R and another one is Q bar. Here you have taken Q. So what about Q bar? Opposite of this one. So 1 means here it is 0 means here it is 1. So 1 and here it is 0. R is equal to 0. See, first case R is equal to 0, Qn is equal to 0 means here it is 1. It is Qn. Okay, so here it is 1. So 1 0 1 0 output is 1 0. What is the output? 0. And similarly here it is 0 and this 0 is connected to this 0 0 0. Both gates are 0 0 means output is 1. Okay, this is the Qn bar. And again for 0 0 and 1, this is the output. Next, R is equal to 1, Qn is equal to 0. Qn equal to 0 means this is 1. So 1 and R is equal to 1. Both are ones. Both are ones. Output is equal to 0. Again 0. And what about this one? Previously we have assumed it as 0. So 0 and again this is 0. Both are zeros means output is this is 0 and S is equal to 0. Both are zeros. Output is 1. Okay, output is 1. That means complement of this one. Okay, now assume the second next state R is equal to 1 and the previous state is 1. So previous state is 1 means here it is 1 means it is 0. So 0 0 is connected here and one more is 1. So 1 0 means output is 1. 1 0 means output is 0. Okay, a little bit confusion is there when you operate with the latches. You should understand clearly. See, I will discuss with red color. See, I'm saying this state now. R is equal to 1 and we have assumed Qn is equal to 0. Qn equal to 0 means this is 0. This is 0. What about this one? This is 1. So 1 is connected here. 1 1. What is the output of NOR gate when both are 1? Output is equal to 0. See. So that's why it is 0. Okay. I'm not saying about this one. Opposite is the case. Okay. If you want to go with this, again 0 here. 0 is connected here. And what is the S in this state? S is equal to 0. So 0. When both are zeros, what is the output? Output is equal to 1. Output is equal to 1. See, 0, 1. Next, go with this case. R is equal to 1, Qn is equal to 1. R is equal to 1, Qn is equal to 1. R equal to 1, okay. Qn is equal to 1. What about Qn bar? It is 0. So now it is 0. So 1 0. 1 0 output is 0. 1 0 output is 0. Okay, we have got the output 0. Okay, in this way we have to analyze each and every state of the NOR gate. And again here next for 1 0 and previous state as 0 output is 1. Here also output is 1. For 1 1, see here I will tell this case because this case is quite important in this uh, SR latch. See here, see carefully. Now I am discussing this case. When R is equal to 1, Qn is equal to 0. When R equal to 1, R equal to 1, Qn is equal to what is the Qn? Qn we have assumed initially it is 0. It is 0 means this is 1. This is 1. Okay, 1 1. What is the output? 0. This is the next state output. 1 1 means 0. Now this 0 is connected here. At the same time, the 0 from the previous output is connected here and it is 0. What is the S value? S value now it is 1. S value now it is 1. 1 0. 1 0 output is 0. See, 1 0 output is 0. So for 1 1 output is 0. For 1 0 output is 0. See the outputs properly, both are zeros. But actually, one is complement to other. If it is Qn, the other one should be Qn bar. That is always a required condition. Both must be, the outputs of a flip-flop or a latch must be complement to each other. One is complement form to the other. Okay, if it is 0, it should be 1. If it is 1, it should be 0. But what is the output in our case? It is 0, it is also 0. If you want, you can go and compare with the other case also, you will get the same. Both are ones in that case. That means in SR latch, the last state where both S and R are ones, the output is an indeterminate state. An indeterminate state. So both are same outputs we are getting. This state is known as indeterminate state. Okay, this state is invalid. It is not valid state in the SR latch. That is the main drawback of the SR latch. SR latch or SR flip flop will not work when both are ones. Okay, and what about this one? What about this one? See, when Q is equal to 0, output is also same. That means past output and present output both are same. Here also past output, present output both are same. That means this state is a no change state. No change state. That means previous output is same, carry forward to the next state. And what about this one? When S is equal to 0, R is equal to 1. R equal to 1 means resets the output. Resets the output. So whatever the previous state is, output makes to 0. This is what the reset is. Resetting operation is done here. Resetting is nothing but output will go to 0. Reset. And see here, S is equal to 1, R equal to 0. R doesn't have any impact. When S equal to 1 means it sets the output. That's why output is 1 in both the cases. This is what the set case. Hope you understand what is the meaning of set, reset, no change and indeterminate. These are the 4 different states available in the SR latch. Okay, so finally we can draw the truth table of SR latch as. So truth table of SR latch. So S R output means Qn plus 1. So 0 0 0 1 1 0 1 1. So 0 0 means previous state, which is Qn, no change. This is called no change. These truth tables are very important. And 0 ones, S is equal to 0, reset is equal to 1, set is equal to 0, reset is equal to 1. Reset is enabled here. That means output is reset to 0. Output is reset to 0. There reset operation is performed. And set is equal to 1, reset is equal to 0. Reset is not having any impact. Set is equal to 1 means sets the output to 1. So it is set. And S is equal to 1, R is equal to 1. As both are ones, it is an indeterminate state. Sorry, it is an indeterminate state. In that case, the output is simply represented as a cross mark. Output is represented as a cross mark, which is indeterminate state. Okay, this is what the truth table of SR latch. This is what the truth table of SR latch. Very important. When S is equal to 0, R is equal to 0, it is not changing the previous state. Whatever the previous state, whether it is 0, output is 0. If it is 1, output is 1. That is the meaning of Qn directly taken. Okay, Qn means whatever the previous state that will be same coming in the next state also. And 0 1 means output is 0, 1 0 means output is 1, 1 1 means indeterminate state. So the main drawback of SR latch or flip-flop is when S is equal to 1, R is equal to 1, the output is an indeterminate state. Output is an indeterminate state. That is the problem. How to avoid this one? So in order to avoid this problem, we are going for the JK flip-flop. We are going to the JK flip-flop. Okay.